Welcome to the Explainer. Okay, let's dive straight into this. I want you to imagine that you are staring down a literal wasteland of tricky, multi-part Cambridge mathematics past paper questions. The clock is ticking down, the pressure in the exam hall is mounting, and you are desperately trying to claim your grade treasure. Today, we are mastering Cambridge AS and A-level mathematics, 9709, but we're also pulling in crucial foundational strategies that apply across syllabus codes 0580, 0606, 4024, 4037, and 4040. We are specifically targeting one of the most notorious areas where marks literally go to die, quadratics and completing the square. We're going to navigate this wasteland together. To set the stage, let's look at a real Cambridge mathematics past paper question, a classic code 0580 scenario. Imagine two typical students facing this down. First, we have Alex. Alex is a hard worker, right? But Alex overloads on raw mathematics facts with zero analytical framework. Alex has memorized every single formula but completely lacks the structure to apply them when the question looks even slightly different from the textbook. On the other hand, we have Sam. Sam rushes through the paper, panics at the sight of an unfamiliar scenario, and completely misses the specific command word requirements, just bleeding easy marks all over the page. Look at their flawed answers right here, side by side, covered in the examiner's red pen marks. It looks like an absolute disaster zone. But don't worry, most students lose easy marks on quadratics, but after this explainer, you absolutely won't be one of them. I'm going to show you exactly what examiners are actively looking for and how to transform those red marks into green check marks.
Here is our survival map for today. We'll hit core principles, then the procedural framework, the method mark strategy, critical analysis and evaluation, and finally top examiner warnings. Let's keep moving.
Section 1. Core Principles and Objectives. Surviving the Unfamiliar Contexts.
So to survive those unfamiliar contexts, we really need to understand a high-stakes challenge that every single math student faces. Why do students find applying concepts to unfamiliar scenarios so incredibly hard? Well, senior examiners consistently point out that students, much like our friend Alex, overload their brains with raw facts and rote procedures. They know how to complete the square perfectly when the question literally just says, complete the square for x squared plus 4x plus 3. They can do the basic algebra in their sleep. But the moment that exact same quadratic is hidden inside a complex word problem about projectile motion, area optimization, or integrated into a tricky calculus question, they absolutely freeze. They lose easy marks because they struggle to apply completing the square concepts outside of a sterile textbook environment. The core principles of Cambridge mathematics aren't just about knowing the math. They're about recognizing the math when it's wearing a disguise. We really need to contrast the flawed approach of rote memorization with the assessment framework's true priority. The Cambridge framework strictly prioritizes analytical depth over superficial breadth. Just doing 500 repetitive practice questions the exact same way, that's superficial breadth. It's not going to save you in the actual exam. Analytical depth means understanding exactly why you are having the coefficient of x, why you are subtracting that squared term, and what the resulting vertex form actually tells you about the physical maximum or minimum point of a curve in reality. Knowledge and understanding are just the baseline. The real marks, the A-star marks, are found in application and analysis.
The theoretical architecture of quadratics and completing the square rests firmly on these three pillars. Number 1. Precise definitions. You need to know your mathematical vocabulary inside and out. If the question asks for the discriminant, you need to instantly lock on to exactly what that means. Number 2. Causal relationships. Understanding that if you change the a value in a quadratic equation, it causes a specific graphical transformation, like a stretch or a reflection. But number three is the absolute game changer. Cross-topic connections. Principal examiner reports explicitly highlight that candidates who reference cross-topic connections achieve significantly higher marks. Imagine linking completing the square to finding the exact range of a tricky function, or using it to solve a complex trigonometric identity, or setting up a difficult integration problem. Examiners literally love this. It shows you aren't just memorizing isolated silos of information, but that you actually see the entire mathematical landscape. When you integrate quadratics with other syllabus areas, you elevate your answer from average to A-star territory. This sets up the critical analytical thinking we need for our next phase.
Section 2. The procedural framework. The step-by-step blueprint. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
All right, let's break down the strategy. Systematic processing within quadratics and completing the square follows this exact standardized sequence. This is your step-by-step blueprint for success. I want you to treat the math problem as a manageable sequence rather than a sheer cliff face. Step 1 is to deconstruct the question. Look closely at the command words. Are they asking you to solve, show that, or determine? We use something called the PEEL framework to structure our mathematical thinking. PEEL stands for point, evidence, explanation, link. Deconstructing the command word is your point. You identify exactly what is being asked. Step 2 is to extract relevant data. Pull out the numbers, the constraints, the given equations. This is your evidence. Step 3 is to select the analytical framework. Decide that completing the square is the right tool for the job. Step 4 is to execute with clear notation. This is your explanation. Perform the analysis with crystal clear working. Do not skip lines. Do not try to be a hero and do the math in your head. Verify your results as you go. Step 5 is to present with correct terminology. This is your link back to the original question. Present your final answer in the appropriate format requested by the examiner. Now let's do a quick interactive challenge. I am putting 30 seconds on the clock right now. Look at the 2 student answers on your screen and spot which one actually follows the Peel framework we just talked about. Look at how the first one just lists numbers, while the second one makes a point, provides the evidence from the equation, explains the completing the square steps, and links the vertex back to the word problem. 10 seconds left. Can you see how the Peel method naturally forces you to hit every single assessment objective? Okay, time's up. If you pick the second answer, you are already thinking like a top-tier candidate.
Section 3. The Method Mark Strategy. Rewarding the mathematical process.
Okay, this is the transformation phase. This is where we watch those brutal red pen marks transform into beautiful green check marks. This is the absolute secret of how top students structure their answers to capture every possible mark, even if their final calculation is entirely off. Think about it for a second. Have you ever spent 10 whole minutes on a really complex algebra problem, made one tiny arithmetic mistake on the second line, like maybe dropping a negative sign or adding instead of subtracting, and ended up with a completely wrong final answer? Under a harsh grading system, that is a 0. But Cambridge doesn't always work like that. If you know how to logically display your work, you can salvage almost all of those marks through the method mark strategy. This is an assessment approach where credit is awarded for the analytical process, the execution of clear working and logical sequencing, rather than just the final answer. Examiners are actively looking for clear annotation and verifiable results in your working. The subject specialists who design these Cambridge mark schemes intentionally build in M marks for method and A marks for accuracy. If you drop a negative sign but your process for completing the square is logically sound and clearly written out step by step, you will still secure the method marks. I'm putting a 60-second timer on the screen. Try rewriting Alex's flawed answer right now using clear steps. Notice how as you physically write out the sequential logic, you are building a safety net. But remember, if your page is a messy scramble of numbers without sequence, the examiner cannot legally award you that credit. You have to make your logical sequence undeniably visible.
This table breaks down exactly how to make your work visible and verifiable. Presentation of information in Quadratics follows strict conventions. You need proper headings to guide the reader through your logic. You must use correct academic terminology. Don't write the bottom of the U shape, write the minimum vertex. Your formatting needs appropriate layouts, and your notation must feature perfectly clear annotation. When you adhere to these strict presentation conventions, you are speaking the examiner's language. You are showing them that you are a serious candidate who respects the discipline of mathematics. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Section 4. Critical Analysis and Evaluation. Evaluating the evidence. Let's get into our interactive workshop.
I want you to look at the complex mathematics data source on your screen, a challenging chart mapping a quadratic real-world scenario. Let's kick off Challenge 1, the data scan. I am putting a 60-second visual countdown timer on the screen right now. You need to scan that data. Data interpretation skills in quadratics are absolutely critical. Extract the core trend from the table. What are the mathematical relationships? Are the roots real? Are they imaginary? What does the discriminant tell you before you even pick up your calculator? 30 seconds left. This rapid data scan is the hallmark of an A-star student. They don't just blindly calculate, they interpret. Okay, time's up. Now for Challenge 2, find the flaw. Look at the flawed sample paragraph on the screen analyzing that data. You have to identify the exact sentence that is losing marks. Read it carefully. Did you catch it? The student failed to identify the limitations of the model. To push your answers from purely descriptive to highly evaluative, you need these 4 critical steps. First, identify limitations. Does this quadratic model only apply for positive values of time? Because time can't be negative, right? Second, spot assumptions made. Are we assuming no air resistance in this projectile motion quadratic? Third, consider alternative interpretations. Could there be 2 valid solutions mathematically? And if so, what do they actually represent physically? Fourth, track the effect on conclusions. If one of our assumptions is wrong, how does that physically shift the vertex of our parabola? This find the flaw mindset is what separates good students from great ones.
This brings us to a really sharp distinction: generic answers versus justified recommendations. Remember Sam, who rushes through the paper? Sam provides generic, lower-scoring answers that are completely out of context. Sam might solve a quadratic and find that x equals -5 and x equals 2 for a length measurement and just leave both answers sitting there on the page. But top-scoring candidates demonstrate evaluative thinking. They question assumptions, they consider different perspectives, and they justify their decisions with evidence. A top candidate will explicitly write, since x represents a physical length, the value must be greater than 0. Therefore, x equals 2 and x equals -5 is rejected. That is a justified recommendation. All right, challenge 3, speed writing. You have a 30-second timer on the screen starting now. I want you to write one perfect Peel paragraph justifying why you reject a negative root in a time-based quadratic equation. Go, make your point, state your evidence from the math, explain the physical constraint, link it back to the final answer. 10 seconds. Keep writing. Clear and concise. Time. That is exactly how you use the Peel framework in a mathematical context to secure the maximum available marks.
Section 5. Top Examiner Warnings. Avoiding the trapdoors. Let's look at the final system.
We have dug incredibly deep into the Cambridge Principal Examiner reports for quadratics and completing the square to find specific data about student mistakes. These are the trapdoors that catch thousands of students every single year. You need to know exactly where they are so you can confidently step right around them. I want to present this massive examiner alert to give official weight to our strategy. Direct quote from the examiners, the classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario. This happens so frequently that examiners practically beg students to stop doing it. If the question is about the profit curve of a business modeled by a quadratic equation, your final answer shouldn't just be the maximum is at x equals 4. It absolutely needs to be the maximum profit occurs when 4,000 units are sold. You must always link every single analytical point back to the given scenario. Context is king in Cambridge mathematics. This leads us to our final system, the 3 rules that guarantee top marks. Rule 1, command word decoding. Rule 2, PLL framework application. And Rule 3, the time management matrix, knowing when to move on if you are stuck, but leaving enough clear working to grab those method marks.
So here they are, punctually listed, the top 3 mistakes straight from the grading room. Mistake 1. Examiners report that students constantly confuse cause and effect in quadratics. They mess up the graphical transformations completely, confusing a shift on the x-axis with a shift on the y-axis when dealing with completed square form. Remember, inside the bracket affects the x-axis inversely, outside the bracket affects the y-axis directly. Mistake 2. Students forget to check format and presentation conventions. They do all the hard math but present it so poorly, with such messy handwriting and chaotic layouts, that they lose the method marks we discussed earlier. And mistake 3. Providing answers not specific to the given context. Do not be like Sam. Always ground your math in the reality of the question.
Here is a quick memory hack pulled straight from our source data to aid your retention under exam pressure. Use a visual story method to encode quadratics and completing the square concepts. I want you to imagine completing the square as packing a suitcase for a trip. You have your loose items, your X terms, scattered everywhere. You need to neatly pack them into a perfect square bracket, like folding them into the suitcase. But to keep the suitcase perfectly balanced for the flight, whatever extra weight you added inside the bracket to make it a perfect square, you absolutely have to subtract from the outside. Creating a vivid, slightly ridiculous visual story like this helps lock the procedural framework into your long-term memory. It ensures you don't blank out when the timer is counting down and the pressure is on.
I want to leave you with this final, provocative thought. Think back to the last past paper you attempted. If you had fully applied the method mark strategy, if you had clearly documented your sequence, annotated your steps, and perfectly executed your presentation conventions, how many of those lost marks could you have instantly recovered, even with calculation errors? The answer is usually enough to jump an entire grade boundary. You have the blueprint now. The wasteland of tricky Cambridge math questions doesn't have to be terrifying anymore. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE, to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner.
Ace the exams. Your Cambridge success starts here.